Hi, I'm Yang Wang, and today I will talk about the heart disease for MAT422. The introduction. The heart disease remains one of the leading causes of death worldwide, posing major challenge to public health system. It covers a range of conditions that affect the heart, including coronary artery disease, heart rhythm problem, and congenital heart defects. The growing prevalence of heart disease is concerning given that its impact on quality of life and the economic burden it places on the health care system. The critical need for effective stringent to protect them and manage heart disease highlights the importance of this topic. Advances in machine learning and data analysis offer permission and use avenues to enhance to our understanding and approaching. Mm, Advances in machine learning and data analysis offer permission and means to enhance our understanding and approach to this widespread health problem. In this paper, we aim to predict confirmed cases of heart disease worldwide using support SVM and confirmation risk method. Additionally, we will explore the use of logistics region rejection on the sport virtual machine to predict heart disease risk. Future importance analyze comparative analyze and the risk signification. Our goal is to provide a comprehensive analysis that not only contribute to the academic distribution of heart disease prevention, but also provide partial insight that will be beneficial to health care protections by applying these advanced analysis techniques to heart disease data. We seek to uncover passion and relationships that may be invisible to traditional analysis method. In the following section, we delve into relative literature from or study within the context of extension research, distribute our proposed method and its potential setup, and discuss our findings. Related work. Advanced in machine learning and data analysis have the micro change the risk landscape for heart disease prevention. Heart disease is one of the most common diseases that requires earlier diagnosis to save lives and reduce the machine burn. A study from BMC Biological conduct a comparative analysis of visual classifiers on heart disease dataset, demonstrating the efficiency of a machine learning algorithm providing HD with a minimum number of attributes. The dataset contained data on 70 attributes from 1,025 patients, which was reduced a subset of 14 attributes in the analysis using algorithms such as K, nearest neighbor, name-based babies, and decision tree J48. They achieved significant classification accuracy, highlights the potential of those methods in heart disease predictions. The conclusion drawn from this study emphasize the importance of reliable feature selection method in HD production. It shows that focusing on minimum number of relative attributes can produce effective, efficient, and attribute decisions per mental model. Furthermore, the students acknowledge and complexity of HD, which is affected by multiple factors such as high blood pressure and distribute and triglyceride level. This is actions for SVM and for each method. In persist method, our study suggests that the use logic regestion and SVM to prevent heart disease. This method was chosen for their effect in handling brain classification problems such as the possession or absence of heart disease. The logic reason method. The logistic regression model in our study will be configured with specified permission to promote if it's permissive. The regularization range C will be set to prevent overfitting. Class Y will be balanced according to the formula, and this is the formula. To provide fair learning of both classes, considering the number of samples and features in our dataset during incremental and linear so will be used. We will train the module use the heart disease dataset split into training and test set. The model will be fit using the training data X train and Y train and make predictions on the test data X test. We will use the function measures to evaluate the utterance of the model, and the utterance is expected to be similar to or extend the previous research result of 89.47%. And the SVM method. We will use SVM as its very effective classification task, especially in medical data sets such as heart disease. The ability of SVM to handle high-dimensional data make it suitable for our data set, which with multiple attributes. The current kernel type and the partial parameters will be carefully chosen to multiply the parameters of the model. This choices will be based on probability tests to determine which configure products to the most occurrence per sections. Experiment setup and result discussion. Model training. The logic rejection model will be trained on the training side. We will try different methods such as regularization string C and class Y to find the best configuration. The performance of the model will be evaluated on the test site. Key metrics include by cited and the area under the ROC covers the confusion method will be used to element the predictive ability of the model. And this is the result in picture. The SVM setting, kernel selection, different kernel function will be evaluated to determine the best fit for our dataset. The SVM model will be trained on the training site parameters such as the parental permission and the grammar value will be adjusted to optimize the performance of the model evaluation. Similar to logic registration, the performance on the SVM model will be elevated on the test site using utterance and the ROC covers. The result shows the occurrence of SVM treating and testing is 86.83% and 83.41%. And this is a confidential measure for SVM. Comparison. For the information collected, SVM can sometimes achieve high accuracy, especially in data sets where the relationship between feature and argument is complex and nonlinear. However, LR can be more forward to implement and understand, which may be preferable in citing where interpretability is a property. In summary, the truth of LR and SVM in hard decision processes should be guided by the special characteristic of the data set, required model interpretability, and available computational resource. Result from various students indicates that which will both model can provide high accuracy, model selection should also consider unity and the case of integrating the model into the medical decision-making process. In conclusion, our comparative analysis shows that which both models have their merits. That's true. The truth between them is not a question of sequential, but the suitable ability for the test at handle LR stand out in some manner which interpretability is cruel. Commercial SVMs come into play when the data set is a non-linear partial that requires complex model. As we conclude, the limitation inherent in analyzation effect must be acknowledged. The performance of the model depends on the quality of the data and the representatives of the sample. Additionally, the evaluation landscape of machine learning and medical research requires conclusions referred for the predictive models to keep pace with new discoveries and techniques. That's all. Thank you.